Here we have another question, question number 67. It states that the limit of this following function as x approaches 3 equates to what? And so again, we want to look at the one-sided limit. So the one of them that we're looking at is as x approaches 3 plus, again, meaning from the right-hand side. And then the other one would be as x approaches 3 minus, right, from the left-hand side. So we're looking at both our one-sided limits, right? And clearly we look at from as x approaches 3 from the right hand side, we see that it's approaching infinity, right? So this is equal to infinity. Now as x approaches 3 from the left hand side, that is also approaching infinity. Therefore our one-sided limits are equal, and therefore our overall limit is also, I mean, it obviously exists, right, because the one-sided limits are equal. Therefore the answer to question number 67 here is it is equal to infinity. Now this brings an interesting concept, right, because we know that removable discontinuities, whenever the removable discontinuity is present, right, the limits do exist, right? The limits do exist. You have this concept of approaching the whole, right, that is formed. Now when you have a jump discontinuity, then your limits do not exist. So they do not exist. And again, the reason is if you have that jump, right, you know, you see that if you have this jump, then when you're going from the right hand side and when you're going from the left hand side, you will not be approaching the same value because of that jump, right? That causes a difference you know, between the y values, right? So you will be approaching different y values from the right hand and the left hand side. So when there's a jump discontinuity present, the limit will not exist. So limits do not exist. So we have removable discontinuity and we have jump discontinuities that we have gone over. This one brings in that concept of asymptotic discontinuities. So we have asymptotic discontinuities. And so looking at asymptotic discontinuities, this is an excellent example because we have a vertical asymptote at x is equal to 3. And so this one over here does prove this idea that that even if there is an asymptotic discontinuity present, if there is an asymptotic discontinuity present, then the limit may possibly exist. As you see here, there is an asymptotic discontinuity present, and the limit does exist. The limit is infinity in this case. However, you may have something like, I don't know, for instance, say that instead of this curve, you had something like this, right? If you had something like this, so you had this and you had this, and then you had the same question as limit of the following function, or it would be a different function in this case, but assuming you knew the function, you would say that limit of that function as x approaches 3 does not exist, because although you have this asymptote right over here, as you approach from the right hand side and as you approach from the left hand side, you're getting different values, right? You're getting positive infinity for one, negative infinity for the other one. So really what I'm trying to say here is that when you have asymptotic discontinuities, your limit may or may not exist. For jump, however, limits, you know, usually or almost any limit you see will not exist when there's a jump discontinuity present, and whenever there's a removable discontinuity present or there's a hole that you see, limits will always exist. So that's just a basic concept that you should understand by now. So that's problem number 67, and its answer is infinity over here. So thanks for watching.